So once in a while, I come upon an article with a title like, Russia deploys giant space telescope in Lake Baikal. And I go, huh? What are you up to now, Russia? Hello wonderful person, this is Anton, and let's actually talk about this because I know exactly what it's about, and despite this somewhat misleading headline, it's actually a really interesting story. Which also kind of makes it true. It is actually a space telescope, but it's not exactly what you think. It's not a Hubble. It's what's known as a neutrino detector, and it's an extremely interesting project that's been going on for a very long time. First of all, a little bit of geography. Lake Baikal is this humongous body of water you see right there. It's the world's biggest depository of fresh water, and it's also extremely deep. Now because of this, it also has a lot of really pristine water, and technically some of the cleanest water, that is absolutely perfect for certain scientific experiments. And so back in the 80s, the Soviet scientists proposed that we can technically use this lake to create a very powerful neutrino detector. Technically a space telescope, but it's not really looking at light, it's looking at neutrinos coming from distant objects. You might already know one of these very famous neutrino detectors, we've already talked about this on the channel several times. The neutrino detector known as IceCube. This one is in Antarctica, and it's essentially this really massive network of suspended detectors that go as deep as almost 3 kilometers into the ice, containing a bunch of these detectors that sort of look like this. And the premise of this device is as follows. As the neutrinos coming from really distant places in the universe go through this location, they start emitting very specific radiation that can then be detected and precisely tracked by these detectors, with the radiation itself being created as the neutrino interacts with the molecules of water located inside ice. And this can then create this very precise 3D image of where this particular neutrino came from. It's been done several times already, and it helps us understand the origins of these very powerful events that probably happen in distant galaxies and possibly came from various supermassive black holes or some other really powerful events around the universe. But this time it uses the effect known as Cherenkov radiation that is created by neutrinos as they pass through water. Cherenkov radiation, by the way, is the reason why nuclear reactors glow in this way. This is an image from the US Department of Energy, and what this shows you is the effect created by particles that manage to move slightly faster than the speed of light in this particular medium. And in this case, when a charged particle moves through a certain medium like water faster than the speed of light in this medium, it actually creates these very unusual effects. And so, for example, if another particle coming from another galaxy passes through water and it goes really fast, faster than the speed of light in the water, it will also produce these tiny light variations which can be detected with very sensitive detectors. One of the first detectors to use this was actually in Japan back in 1982, and because of this, this is also sometimes known as the Super Kamiokande effect or Super K effect. And so very similarly to IceCube, as the neutrinos pass through the very fresh waters in Baikal Lake, they're going to be also interacting with the water molecules inside and producing these very fast moving electrons which then start emitting Cherenkov radiation. This radiation can then be detected by these sensors, but unlike the IceCube neutrino detector, where it's all sort of set inside ice and doesn't really move much, in this particular case, because it's in a lake, it's usually attached to the bottom of the lake and kind of looks like this. With the main advantage of course being that you don't have to drill into the ice and you can basically just sort of gently place all of these strings with detectors slowly onto the bottom of the lake. And because the lake is actually also very deep, it's almost 2 kilometers in depth, it sort of prevents any other interaction with any other particles or any other radiation coming from planet Earth or from any other source that might disrupt the data. But one of the main reasons why IceCube neutrino detector is actually kind of famous is really because of its sheer size. It's pretty big. Not to mention the fact that it's also in the middle of Antarctica, which is a pretty remote location. But what the scientists in Russia are now trying to do is essentially create something akin to IceCube in terms of size and in terms of total volume, but also create a neutrino telescope that's going to be able to operate in the northern hemisphere, because as you can probably imagine, the neutrino detector here is only able to detect things in the southern hemisphere, near Antarctica. And so the eventual plan for the Russian scientists is to have something that's even larger than IceCube right here, something even more complex in terms of the amount of sensors and of course the amount of neutrinos it can detect. But officially they actually started measuring all of this back in 1995, and back then the telescope or the detector was actually really small, at least comparatively speaking. So if this is what IceCube kinda looks like right now, the Russian facility back in 1995 only had about 36 of these detectors and actually only 3 strings. So it was a tiny fraction of what you see on the screen. By 2005, this number has increased to 200, but it was still not even close to the amount of detectors in the IceCube. Although I guess it's unfair to say that because IceCube didn't even exist back then. But in total there are close to 5,200 different detectors in here, so it's definitely a lot more. Which also allows it to create much more accurate picture and detect a lot more neutrinos in general. But less than a week ago from when I'm making this video, the Russian scientists announced a major upgrade to their system, creating 8 different clusters with almost 300 detectors on each cluster, which is about 2,300 detectors, or is roughly around half the size of IceCube, with the total volume being about half a cubic kilometer, and that's just the first stage. The plan now is to at least double this in the next few years, making this essentially very similar to what we already have in Antarctica. And this will actually be absolutely mind-blowing because we'll have these 2 very powerful neutrino detectors operating from both sides, from both hemispheres, allowing the scientists to possibly discover really cool phenomena that we just didn't really know existed or that could not be detected previously. For example, there are already different studies trying to investigate the signs of potential dark matter inside our sun, thus solving the mystery of dark matter. And the upgraded version of this neutrino detector should be able to give scientists a lot more clues about what's going on inside the sun and if there's really dark matter hiding there. And all of this is really exciting because, well, neutrino observatories and just the idea of observing neutrinos coming from various objects around the universe is actually still a very young field. It's really in its infancy. Even though there are several detectors around the planet, they're usually really hard to maintain and to build because they have to be isolated from everything and normally have to either be built underground in very remote locations like in Antarctica, or like in this case, in a remote location in a very pristine, clear lake on the bottom 2 kilometers deep inside the water. But unlike other telescopes, the ability to detect neutrinos is also really important in order to study various very cataclysmic events. For example, the famous 1987 A supernova that created this beautiful image that you see right here and occurred back in 1987 in the nearby Large Magellanic Cloud was one of the first times ever that we actually detected neutrinos coming from the location, which allowed the scientists to tune in and see what's going on in there, which of course helped them to detect the supernova itself. It also helps us discover mysteries of various powerful galaxies, powerful events happening in those galaxies, while also helping us identify very powerful events inside our sun, and thus helping us learn about what's happening inside our sun, or maybe even predict certain events, such as very powerful emissions that could somehow affect planet Earth. And with only a few neutrino detectors currently operational on the planet, and with most of them already being cancelled or just not used anymore, the additions to these Baikal telescopes are currently very much needed for a lot of different research that will definitely help us answer a lot of questions about the universe, a lot of questions about our sun, and will hopefully help us discover a lot of different things out there in the galaxy and the rest of the universe that we just didn't really know existed because we didn't really know what to look for. But since a lot of things do emit neutrinos, and since neutrinos form such a huge amount of mass in the universe, representing pretty much the same amount of mass as actual atoms in the universe, we definitely require different ways of being able to detect them so that we can actually understand the world around us much better. Otherwise, we are probably just missing a lot of possible answers to different questions. So in a nutshell, it's a really cool field of study. So cool, as a matter of fact, that a lot of different communities around the world are trying to create their own now. For example, in Europe, they're trying to make something similar, but inside the Mediterranean Sea. The detector is kind of going to look like this, and it's already known as KM3net. But it's not really clear when exactly it's going to be finished just yet. So for now, it's really that Russian neutrino detector or Russian telescope that's going to be able to detect the most. At the same time, it's not really truly just Russian. It's actually a European community as well, with several other scientists being from Germany, Poland, Czech Republic, and a few other countries in Europe, essentially making this a truly international achievement. And because in the next few years they're going to be expanding this to around 1 cubic meter in volume, it's going to be a very impressive achievement and an extremely important telescope, a space telescope located in a deep lake. So that's kind of cool. And hopefully one day I'll get to visit this, because I heard it's an amazing location for a lot of different reasons. And it's definitely a lot easier to visit than this place right here in Antarctica. But anyway, on that note, that's all I wanted to mention in this video. We have this old neutrino detector that became much more powerful since its original inception in 1995, and is going to be pretty much as powerful as the IceCube neutrino detector in a few years from now. And the whole premise here is that we're going to be able to detect these very powerful emissions from very powerful cataclysmic events happening around the universe, now from both hemispheres. IceCube can cover the south, while the detector in the Lake Baikal is going to be covering the north part of the planet. So it's a win-win for the scientific community. On that note, thank you for watching, subscribe if you still haven't, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, and maybe support this channel on Patreon by joining the channel membership or by buying the wonderful person t-shirt you can find in the description. Either way, stay wonderful, I'll see you tomorrow, and as always, bye-bye. Okay, quick side note, I mentioned Cherenkov radiation, but I cannot not mention this. This is also the reason why plutonium in the Simpsons is also glowing. It's basically Cherenkov radiation, which is also used in these neutrino detectors to detect these particles that are moving faster than the speed of light in that medium. Okay, that sounds really complicated. Basically, it's glowing because those electrons are moving faster than the light in the air. Although I'm sure Homer Simpson knew everything about it. Anyway, that's it.